Okay, here we go. Chapter 8, Lesson 5 on page 384. We finally hit those problems called dirt. Dirt. Distance is equal to the rate times the time. These will be tough for some students, but if we go slow and we make some tables and we understand what the words are telling us, we can usually come up with a solution. Don't sweat it. We'll go slow. Number 3 on Chapter 8, Lesson 5 begins our first homework problem. It says, we have, let me get the book here. A train leaves the station and travels east at 72 kilometers per hour. There it is. And 3 hours later, a train leaves and it travels at 120 kilometers per hour. So let's put that in there. Let's put that in blue. So this one leaves at 120 kilometers per hour. And it made this table for us. And it said, draw a diagram that represents the situation. Label your diagram using the data. Copy of the data, and let's see if we can come up with a solution. Well, the interesting thing is, this train leaves 3 hours after this one. So from the time perspective, this one left and took 3 more hours because it was behind this one. Let's think about that for just a second. The second train leaves at 120 kilometers per hour, but it left 3 hours later. The table said that was going to be the time. Well, if we think about the slower train, the slower train had to have 3 more hours because it left 3 hours earlier. And it turns out that the question is, when will they both be exactly the same distance? Let's see if we can draw our picture. So we have one train that leaves going 72 kilometers per hour. The second train leaves 3 hours later and it's going 120 kilometers per hour. And the question is, 3 hours later, when will they catch up to each other? When will they be neck and neck? Both headed east. So let's see if we can figure this out. Well, the distances are going to be the same, and the distance for the first train turns out to be 72 times t plus 3. And the distance for the second train that had the head start is 120 times t. I should have made those t's lowercase. Sorry about that. And the question is, for number 3, when will the faster train catch up to the slower train? And at that time when it's catching up, their distances will be exactly the same because he's been catching up slowly behind, and then finally he's neck and neck, even though he left 3 hours later. So that tells us that this distance and this distance are the same, or that 72 times t plus 3 better be equal to 120 times t. Or if we distribute, we have 72t plus 216 is equal to 120t. And if we subtract 72t from both sides, we end up with 216 is equal to 48t. And if we divide both sides by 48, t turns out to be equal to 4.5. So in 4.5 hours, the slower train will have overtaken this. The faster train will have overtaken the slower train. That's what they were asking us for. Another question you might ask is, well, how long has the slower train been traveling? This is not part of the problem. Well, that answer would be 4.5 plus 3, or 7.5 hours. So when will the slower train overtake the faster train? At 4.5 hours. Let's try another problem. Number 13 on page 385. This one is, let's see. Motorcycle guy is going to work. He's going to travel 25 miles all total. It's going to take him 2 hours to get to work. Driving his motorcycle at 45 miles per hour. He breaks down though, and he ends up walking at 6 miles per hour till he gets to work. Kind of a bummer. So he's traveling 45 miles per hour for some distance, breaks down, then he has to walk the rest of the way. And the question is, how far did the motorcycle go before he broke down? So let's see if we can figure this out. We don't know what this time is, but we know what the total time is. This time here is t. from here to here, where the motorcycle is driving at 45 miles per hour, that time is t. The total time is 2 hours. So the time up here when he's walking is 2 minus t. So let's put that as 2 minus t. That's his time. So he drove for 45 miles per hour. So the distance on the, So the distance on the motorcycle turns out to be 45 times t. Distance times rate times time. And the distance that he was walking turns out to be 6 times 2 minus t. That distance, we don't know what it is, but it was 6 miles per hour times the time, which was 2 minus t. And both of those added up are going to be the total distance of 25 miles per hour. So 25 turns out to be equal to 45t plus 6 times 2 minus t, or 25 turns out to be 45t plus 12 minus 6t, or this turns out to be, if I do my math right, 13 turns out to be equal to 45 take away 6t is 39t, or t, if I divide both sides by 39, turns out to be 1/3. So he drove for 1/3 of an hour at 45 miles per hour. Then he had a blowout and his motor broke down. Then he had to do the walking. Careful of what the problem asks you. It says, how far did the motorcycle go before he broke down? Well, we know what that answer is right here, because the distance the motorcycle went at 45 miles per hour was 45 times 1/3 of an hour, or the distance turns out to be 15 miles. So our solution was he drove the motorbike for 15 miles, then he had to walk the rest of the distance. So our solution was 15 miles. I might ask you the question, how far did he have to walk? Well, he walked for 10 miles because he drove for 15, then he walked the rest of the way, and that was another 10 miles. So the solution to this problem was 15 miles. Remember, it helps to draw a picture, understand what we're asking, and usually we can come up with our solution. Thanks so much. We'll see you guys all tomorrow.